My talk is a little bit different than the other talks because I'm not going to talk about how to implement or any of the systems that I'm implementing right now, but more why I see companies failing to implement cutting-edge machine learning systems. So just to clarify, the last big company I worked for was Netflix. Netflix currently spends $150 million a year on recommendations. They have a team of 300 people, of which 35 are machine learning engineers. I left Netflix 4 years ago. I wrote their recommendation system. It was not part of a team. I wrote every single line of that code. Whatever you hear in Netflix blogs is totally fake. In the past 4 years, every single A/B test has failed. The same recommendation system that I built is still in production. Why is that the case? I mean, obviously, they want a better recommendation system. I've seen this in a number of companies where they make the same mistakes again and again. This talk is about those mistakes that I see. OK, so Netflix is an example of a company which is finding it very difficult to improve their an important fundamental system, their recommendation system. Number one reason is machine learning is hard. Not installing a package and then using that package by following instructions, but actually developing the mathematics for new machine learning systems. If you become adept in this area, there's two great sources of inspiration to develop new sorts of models. One is the mathematics, and the other is the actual code, which you can view as a modern type of mathematics. Manipulation of that code yields insight into what you're actually trying to do. OK, so a lot of companies have a pipeline where they have a research group doing machine learning research and a production group of software engineers actually pushing that into production. But this doesn't work. It's always the case that the machine learning group and the software engineers have totally disparate skill sets. And there's a breakdown of communication between the two where the systems produced by the machine learning group are not actually implemented faithfully in production. And the sad thing is that neither group really understands their work and their worth to the company as well. And it's often the case, I've been told not to use the word perverse, but sometimes I think it is a perverse incentives that the senior managers within these companies are rewarded not for improving the bottom line performance of their systems, but actually for managing more people. So this is the next slide. This is from an interview a few years ago from the creator of C++. And you'll see that these major figures in languages and computer science actually understand that this is a problem where they identify that actually software design is very difficult. And the mistake that they see in big organizations is that they lump together highly skilled software engineers with middle skilled who are still learning the craft software engineers and all contributing equally to the code base. If you have people contributing equally to the code base, then it's what's going to happen is that the good people are going to be swamped by the semi-skilled people. And it's a sad case now that software engineering, to a large extent, is devalued. These coding boot camps fulfill a vital educational role, but unfortunately, what happens is these big companies look for low salaries, look for numbers to build up their teams. They don't think about the impact of having semi-skilled people altering code, which impacts everybody. And the same goes now recently with data science boot camps, where you, in 12 weeks, can apparently learn all about data science and be able to implement cutting-edge systems. The reason why I dwell on these aspects is, as I said right at the beginning, if you have the code and the mathematics behind the code provides a vital inspiration into developing new mathematical techniques. But if you're, for instance, at some of the companies that I've been working with, working through layers and layers and layers of objects to finally find the 5 lines of code which actually does anything, it basically destroys any sort of innovation that you get. So many of you will probably know this, but I'd like to go through this classic humor that you've seen before to sort of illustrate the conversations that you have in day-to-day in these big companies when you're maintaining a piece of software project. Here's a very simple piece of code which illustrates, how to do something very simple, which is print out "Hello World." When a software engineer becomes more experienced and more senior within the company, this is something that he might write. Now, here's a case where he's learned the importance of comments, he's learned the importance of factoring out constants into globally so they're not replicated in the code. All perfectly valid reasons to structure the code this way. It's hard to argue against this when you're doing a software review. Okay, when you become more experienced, okay, you might get something like this. Now, this is, of course, a very simple example, but code like this I see all the time in big companies. I mean, I remember at Google reviewing a 300-line class, or multiple classes, which are basically 4 integer counters. And when I asked, why didn't you just implement this as 4 integers? The reply was, first of all, he just looked at me like I didn't know what I was talking about. And second, it's more modular. So it's a simple example of what happens in the real world. And in this case, the engineer has learned about JavaDoc, which is great. And he's learned about constructor, which is great. And it's very difficult to argue against these facts, these attributes in a code review. But notice how the difference between this and this. Same functionality, but in an abstract sense that a software engineer learns in university. This is better code because it's more modular, quote. And in year 5, you may produce something like this. Now, this person will now be a very senior engineer within the company. And this is the enterprise version of Hello World, where now you've had extra flexibility. You've now decomposed the Hello World phrase into the greeting and the object. You've had setters and getters. And you've even learned a little bit of legal parlance and have a license disclaimer at the top. And this is this is only half of the code. So, and that's the rest. Again, you go to a software review, it's very difficult to argue against any, wonderful, he's even got dependency injection here. So, and obviously dependency injection is good because it allows you to test much easier. But notice that this is doing exactly the same as this. This is the code that you tend to see checked into a code base at Google. And of course, at year 10, when you realize that, the only thing that matters is whether it works or not, brevity is is understanding code is meant for a human to read. This is what a real guru would write. Nice thing is that, the skills to write this, the first year graduate has the skills to write this. He just needs the confidence to ignore all of the noise that he gets exposed to. Okay, so if you're battling with this sort of code every day, okay, and you're trying to implement a machine learning method within a company like Google or Netflix or Cisco or whatever, it's very difficult to focus on the mathematics or evolving the model. You're fighting this code every single moment, and you have no cognitive energy to spare. Okay, so what's the solution? Okay, so you really have to focus on what's good code. So, I'm sure a few of you have the same view as I do. I know many in private do, but they're frightened to speak out, because saying this sort of thing in a company does not do any good for your career. In this talk, I'm free to say whatever I want, so I just want to expound this. And this is another quote from the same interview from the creator of C++. The rules for writing good code is the same for rules for writing good English text. Say what you want simply. Okay, the question is, what is simple? Everybody has their own opinion, but my own opinion from writing code for 30 years is is code which you can read and understand what it's doing from a small context. Functional, by definition, is, fits this perfectly. Unfortunately, languages like Java, I'm mostly a Java programmer right now. I used to be, 5 years ago, a C++ programmer, but are only just moving over to the functional approach. And the constructs that they have natively in those languages are very verbose. There's imperative, which is basically functions which take arguments and do something on data states. Object orientation, everybody knows what that is, and patterns, et cetera, and higher levels, like dependency injection. I've ordered those points in terms of the amount of context you need to understand the functioning of a piece of code. Now, this is not meant to be a recipe for writing good code that you always should follow, but when you're looking at a piece of code, you should look to see what level is appropriate for that code. You can write any code you want in a functional way, but often many pieces of code, if you wrote them in a functional way, just becomes huge and verbose. It's better to drop down to the imperative or the object-oriented approach. The key is, I love the language Python, okay, because they really push the conciseness importance of, if you ever read the Zen of Python, conciseness becomes very important there, and it's a beautiful language to work in. The downside, I don't use Python very much from day to day, only for prototyping, purely because it doesn't have strong typing, which is essential when you're producing a production system. You want the language to do as much as the testing as possible. So functional, imperative, object orientation, and patterns are ranked in the order of the amount of context that you need, but unfortunately you can't write everything in functional method because certain things become so complicated that it's better to move down the list. So why do, even nowadays, object orientation is widely used. And when I, for instance, in code reviews, object to a certain architecture of building a system, I'm often overruled. Why do I dislike it? Well, there's a huge number of reasons. The creator of C++ gives a reason here. So now, if you remember, if you were around in the early days of C++, C++ is basically originally defined as C plus objects. It was defined at a time where objects were a silver bullet to solve all programming problems, to solve the engineering of big systems. You know, a few years after the adoption of C++, the publishing of C++, it was realized that actually it often caused more problems than it solved. And you can see here that even the creator of C++ realizes that it's only a toolkit, a tool that you use to build systems when the other simpler methods, the functional and imperative, turn out to be too verbose. And what he says there is basically the coupling between, if you have, the problem with C++ is it's very difficult to a priori predict extensions of a set of classes, or from the namings of classes predict, convey their full semantics. And so you basically end up having to read all of the code. So it doesn't actually save you very much. Compared to imperative, for instance, where a functionality is indicated by the arguments and the return value, the class's functionality is indicated by the class members, the inheritance hierarchy, which means that you need an awful lot more context to understand what's going on. If you have to understand more of the software, there's less of your brain cycles remaining to focus on the machine learning. And the machine learning members of your team will basically have less ability to implement cutting-edge machine learning and to extend the methods. I can't talk, let me go back to this. So I have 2 slides on object orientation, and the reason I focus this is because Java, which is a much more recent language than C++, is still, although it's changing now, focuses on object orientation, and they still haven't realized, most of the engineers, software engineers have not realized the truths that C++ engineers have realized. And they're Java engineers, because it's taught to undergraduates, they are more junior and don't have the experience. They will tend to produce over-engineered solutions, over-object-oriented solutions. So that's why I focused on 2 slides. So I'd love to, I recommend to everybody to watch these videos. I think the person who's speaks in these videos is very entertaining and brings the points across very clearly. If you, at the very least, look at these videos, and even if you reject the ideas, just keep it in the back of your mind. And when you complete a project, think about what happens if, if you were to code it in a separate way, a different way. And unfortunately, I'm running out of time, but I'd like to very quickly touch upon a lot of cargo code programming, which I see in terms of microservices. Many instances, they're useful, many instances, they're not. Big data, many instances it's useful, many instances they're not. And finally, Hadoop, many instances it's useful or not. If you're not processing 5 terabytes of data, you're better using CSV files on a laptop, okay? And most people are not processing 5 terabytes of data. The recommendation system at Netflix runs on 1 PC in my cubicle. They have a lot of blogs about cloud, etc. All of that is fake. Okay.
Thank you, Sadik. Warm round of applause for Sadik Kapadia here. Unfortunately, we are out of time for Q&A, but I'm sure Sadik will be happy to answer questions to anyone in the audience.